In the last video, we started discussing accumulating area underneath this curve for g of x. And if you go back and look at that, remember we talked about using geometry to help evaluate the definite integral because of the meaning of the definite integral. We practiced taking a derivative using the fundamental theorem of calculus. And more importantly, we applied the extreme value theorem and the candidate's theorem. Now we're going to go a little bit further. So on this one, we're going to do concepts such as applying the first derivative. And I'm only going to worry about the first derivative. In that case, what I'm going to be interested in on is intervals of increase and intervals of decrease. Okay. So we're again going to start by using the fundamental theorem of calculus, the part that tells us how to take a derivative of an accumulation function. Okay, so that's what we're going to start with, but for us, that's g prime of x, and that's going to be, and I would like to see you write d dx, and in our case, the integral from 0 to x of f of y in y, and that's f of x. So f prime, not f prime, excuse me, g prime of x, wake up Mr. Isaac, use the right label, is f of x, okay, and I need that to be 0. By reading the graph, I look up here, I see a 0 at -6, 0, and 8. -6, 0, and 8. Now look, these two are going to be quite boring because they're endpoints. Okay. So now, g prime of x, now if you think about it, and now this is where some of you are making mistakes. This is the interval you care about. Do I care about stuff smaller than -6? Nope. Do I care about stuff bigger than 8? Nope. But if you don't read, you're not going to catch that. So -6, -8, and 0, I have a 0. Okay. Reading the graph, I'm just going to come up here and write this is g prime of x, which is f of x. Oh, look, from -6 to 0, my y values for g prime are negative. From 0 to 8, my y values for g prime are positive. Okay, now we're going to do a couple different things here. Because I could also use derivative tests for this one, so we'll do that too. So we need to work on intervals of increase and intervals of decrease. Okay, so here we go. G is decreasing on the open interval from -6 to 0 because the derivative of g is negative, and don't say on the interval, don't say the derivative, g prime. It's named, use the name. G prime of x is less than 0 on, and just copy the interval and take your points. G of x is increasing on the interval from 0 to 8. Why? Because the derivative of g, also known as g prime of x, is positive on the interval from 0 to 8. That young adult gets all the points. Now, let's apply the derivative test because we've been having issues on that. G of 0 is, okay, let's look at this sign chart. We're going from decreasing to increasing, so that's a local minimum. Is a local minimum. Now they may ask for relative minimums, and if they want relative, you use the word relative instead. Because, now remember what the theorem says. First, it's a critical point, right? G prime of the 0, G prime of 0 is 0. And you just can't say G prime changes signs. You have to be more precise. G prime of x changes signs from negative, and you could write g prime of x is less than 0, to positive, you could write g prime of x is bigger than 0, but you have to say at x equals 0 or about x equals 0. Now, that's all the ways that I can push in first derivative theorems. In the next video, we're going to extend this and take the first derivative of the first derivative and talk about concavity of g. But we'll save that for the next interval. Or I said not interval, but next video.